wildfire at the start, then we turn to ashes, taken by the wind, gone forever. I wish I could go back and turn the table when we were younger. I wish I could change you. We fell out, we were the stars with no light, with snow in July, with the earth with no life. I keep asking myself, how's it happened? Now I'm asking, how will I go on? Now I'm asking all that.
Good evening. Welcome to GameMaker Studio. I'm XP Dev. We are continuing with our game dev journey with learning how to continue to make games in GameMaker by following some of their tutorials. So we've already done the asteroid clone and we've done the breakout clone. Tonight we're going to start with making a platformer. Start to learn a few more tools. We're still just learning our way through GameMaker before we start making our own game. Hopefully we can get started after a few more tutorials, so maybe in the next couple of weeks. Alright. So we're going to be going with a new project. Game. Where is it? Platformer. And we're going to choose our game design folder. Now, what are we going to call this one? So it's originally called Windy Woods. So let's go to our main screen there. Alright, so we're following this tutorial. You'll see on the bottom screen, oops. So yeah, make your own platformer, beginner tutorial Windy Woods from GameMaker. Okay. We'll just call it that. Don't want to waste too much time on thinking about a name for a game that we haven't made yet. Just throw the background up a little bit. Should all be able to hear me properly still. This one's taking a little while to open. I'm still downloading it. Here we go. Alright. The assets browser. This contains all the assets you need to use to make a game. So we should have sprites, sounds. Also, haven't worked with them yet. Sequences, scripts, collisions. It's just like got everything already. But we're going to be making it from scratch. We might not be on that tutorial yet. I did see another one that was a much more basic one though. Let's go filter beginner.
Can you see the stars align? A night like this can never rewind.
Play games.
Can you hear the wolf cry out to the light? A night like this I've never never shine so bright. So take a couple steps back as you hear me start to hum. Take a couple steps back when I lose all control. Watch me turn into a werewolf, and I will hunt till the break of dawn. Don't you dare to try to stop me. This is the horn of the black swan.
Maybe we need to start at the bottom there. Older ones, and they're sort of redoing them again, I guess. But that other platformer one would seem to have like everything all done that we haven't learnt yet. So where's the filter gone there? There. I thought there was a filter for just the visual. Okay, we might do the code one anyway. Need to learn how to do that. Let me check this one though first quickly.
So take a couple steps back as you hear me start to hum. Take a couple steps back when I lose all control. Watch me turn into a werewolf, and I will hunt till the break of dawn.
Okay.
Don't you dare to try to stop me. This is the horn of the black swan.
Alright, yeah, let's follow this one instead. Alright. So we know about the workspace, know about the research tree, resource tree. We can move and drag it around. So you want to keep it on the right there. Okay. So create sprite. So sprite player. You need to have save image as. So why does it still want to do that? Alright, so it's extract. That 0 is there. Let's okay, there we Sprite. Yes. Okay. Change it to middle center. Okay. How about that? We're creating an object. Object player. Okay. And apply the sprite. Edit for default room 0. Room, oh, room 1. Alright. Here's just an instance. Okay, so we're pulling that object in, spacing it, running it middle here. Doesn't do anything though. Okay. Alright, events and code. Stuff and draw, let's talk about the events. Going to add a step. Player add event. Step event. Okay. We are assigning a variable. This tutorial is very basic, beginner, like pretty much back to where we were with the asteroid clone. See on the left of the editor, we have the action written as plain text. Alright. Set X, add 4 to X. Okay. I see the difference there. So much fun for everyone that's not to be coded, make play respond. Use the press the arrow keys on the keyboard. So I've key down. See, this one essentially probably should have been before the asteroid one, honestly. This is like going really basic. Alright, we want proper keys, so we're going to the right, So we're going letters D. If key, checking for a key and only returns if true. Yeah, just to make sure getting that. So yep, move to the right. So we do a copy and paste and change them. So alright, C V E B, nice and easy. So X, and then Y, down -4 up +4. Right, okay, so that one's going to be A -4, oops, not -44, S, Y for -4, and W, Y for +4. Alright. Nice, oops, we've got them around the wrong way. That doesn't seem right. -4. Oh yeah, no, that's right. Because yeah, -4 is going up. Now we've got movement. Okay. Rotation. Okay, build some variable image angle. We've used image angle before. This angle is derived something that's associated to anything other than 0 will rotate the sprite. It's associated collision masked by the amount given. The default is set to 0. For every instance in the room, it can be changed anytime using the set instance rotation. We're going to set the rotation to. We actually need to use a function to get the angle that we want to set the sprite to. We'll store the value it returns in a variable ready to set the rotation of the instance. Take functions and expressions to, not just values. In this case, we're going to use a function to get the direction from the player instance to the mouse pointer and set the image angle to that. Here we go, because this is good, because this is what we're going to want in our game. Alright. First of all, still in the object step play, we need to declare a local temporary variable, add our function to it. So where's the variables? Declare temporary variable. Let's throw this up top here. Okay. A local temporary variable is one that is only valid for the event that it is used in. So it's like a use and throw away variable. We only need to get the direction once in this step. There's no need to make it an instance or global variable. In this case, we have named the variable for direction. In future actions, that will be what we use to refer to it. The function we'll use is point direction. Okay. Point directionist takes 2 positions within the room and returns the direction from the first position to the second in degrees from 0 to 360. In this case, we get the direction from the player position to the mouse position, which we get from the 2 global scale variables mouse X and mouse Y. Global scope variables are variables that do not belong to any instance, but instead belong to the whole game, and as such, all instances can change them and use them. Okay. Angles are calculated anti-clockwise, where 0 is to the right, 90 is up, 180 is left, 270 is down. Okay. Now add the set instance rotation. Set the image of the angle. If you run the game one more time, you should see that the player instance moves around and it turns to follow the mouse. Okay, let's test that. Alright. Okay, so I want to test something because sign variable. Disable that. Disable that. Disable that. Disable that. If we go where's the move? Move it. Okay, so we want the forward and backwards. So that one is the forwards. Set direction variable there. Okay, so now if we copy that and paste it to there, copy that and paste it to there, then -4, let's just test that. Whoa! Why is the speed so much? doesn't like that either. What if we just went... Citizens rotation. Delete them. Copy. Paste. No movement there. Where was that direction one? Same for there. Okay, what's going on? What am I doing wrong? Separated directions and speed. Relative. Copy, paste, -4. Will that do it? Still going really fast. Why is it just adding that? Turn them relative off. Doesn't stop there. And then, okay, this is a test, so key down, key released. So speed, so lock. Same key. I want to test this on this one. So speed 4 released. We want it's gonna be like time.
Doesn't feel like yesterday. It feels so far away. Now you're gone out of my life. You're gone without a fight.
Yeah, delta time. What was it? It's the manual. Delta time. Okay. Wait a second, that's the delta time is let's try to hit a complex graphics complicated. No, but we used it somewhere else. I'm sure we used it in the space rocks in the mods. Power-ups.
Power up variable to 0, then set the ship's color to white. You to collect power up is active. We should in the same pass we're gonna check if our first power up is active. It'll be in the instances layer and modify the done. So let's make a new 20 seconds and we're gonna set this. Let's go the time value divided by 1 million. So delta time is the amount of time that has passed between the previous frame of the game and the current frame, but it's in microseconds, so we need to convert that into seconds by dividing it by 1 million. So by doing it this way, this variable is gonna go down by 1 every 1 second. So in 10 seconds, it'll become 0 and then it'll go negative. So once this variable is negative, that's our signal for spawning a power-up. For that, let's go into obj rock because we want to spawn a power-up when a rock is destroyed. And that happens in the collision event with obj bullets because of course bullets destroy rocks. So at the top of this event, let's add this. We're gonna check if the power-up time variable, which is from obj game, is less than 0. If it is, we want to spawn a power-up. So first of all, we're gonna run the choose function so that it chooses a random power-up from the multiple power-up objects that you can have. Of course, at the moment, we only have one power-up, so that's all we're gonna mention here. And the power-up object that is selected is going to be stored in the obj variable. So we then use that variable to create a new instance from it. We make this instance at the rocks position in the instances layer. So this will spawn the power-up. And after that, we should reset the power-up timer so that the next power-up can spawn 20 seconds after this. So we're gonna set the objgame.powerup time variable to 20. Now before you test this, go into the game room and make sure you delete the power-up that you manually placed there, and then run the game, keep shooting at rocks, and in 10 seconds, you will get your new power-up. Now as a quick bonus, before we add the second power-up, let's make it so you can see how many seconds are remaining.
I think we're going too advanced for what we're doing at the moment, so let's just remove what we've added in our testing. Re-enable those. Let's just make sure we're where we should be. Okay, now we're going to start adding the shooting stuff. So, create sprite. Let's be our bullet. Import. Use the sprite or use the story. Should we place the origin near the bullet image head as shown in the image? So is the point we want to rotate it around and pin it into the room with. If you've used your own sprite, then click the image where you think it would be best to put the origin for the image. So, bullet object. Second. Which apply the events window change it already ready for us to add some code to it, but first we're going to go back to our player and edit that a bit. Okay. The step event we're going to edit now to dynamically create instances of the bullet as the game is being played. Instances don't just get placed in the room editor, they can also be created and destroyed at runtime using certain actions, as we'll see. So if mouse down, just press. Create instance. OBJ bullet. Why is it doing it to the mouse? Okay. Set the bullet instance is the same layer that the instance of object layer is. Using layer name instances for the room editor, all objects are placed on layers. When an instance is created in a room, it must always be assigned to a layer. The layer it is assigned to will affect the render order. It's drawn above or below. Could, for example, have created a bullets layer in the room editor and then use that as to say we want bullets on a unique layer. The action for that would have been a bullets layer. Use this name as an identifier. Target it within this action and a few others. Okay. Y. Okay. Switch to our object bullet. Create event. Event will chain an action editor window to the event editor ready to use. We want the bullet to shoot off in the direction of the mouse. We need to add the following actions. This section with built-in direction variable. Okay, well, I can see it all there. So set point direction. Mouse X. Y. Assign variable. Random range. Okay. It's full. It's relative to the bullet. Set speed. Direction 16. be able to fire. Yeah, so if that was, if we come back up to here, if mouse pressed, so if we change that to if mouse down, let's just disable that for a moment. Unlimited fire, which is not what we want. Not what I want. So re-enable that. We should be back to single clicking. Okay. Let's go back to the room. Okay. Add a new layer for our board, so click the new instance layer. New instance layer. Name it bullets layer. Drag it down. I see. Depth near the camera is the lower the depth further away. So a layer at depth 200 will draw under a layer with depth 300. To object player, change it to that. Bullets layer. I mean, it was already being created under it anyway. Alright. Let's create one, give her a game frame. Turn the game looks around 4 steps, a bit too fast for what we require. So just slow down the rate of fire for this new create event. It's preparing a variable cooldown. Create event, assign variable, cooldown. Each instance of 100 instances of object player or instance variable cooldown. This is variable in the step event with the player object to control how often the shooting occurs. Okay, so mouse down. If variable. If variable cooldown is less than 1. Create object. Assign variable cooldown to 3. Cooldown -1. That needs to be relative. Let's test what it does. Ten. A little saw. Cool. Okay. With the shooting section of my first game, let's pass over the core concepts and things you should know after completing the tutorial. Alright, you should have a player should move controllables at time to come out at regular intervals for the next phase of the game. You must have some form of goal to achieve, more often than not than shooting at enemies. We can take a moment to speed the game up and make it feel more responsive. Okay, so game options. Already at 60. So if we change it to 30, let's see how that responds then. Oh yeah, that's sluggish. Or if we went 120, can GameMaker handle 120? Yeah. Why don't... I'm sure I had fraps installed. So let's first work with that. Yes. Oh, look at that. We got a steady 120. I like that. Cool. Awesome. What if we go 144? Because that's what my monitor is. That is smooth as silk. Alright, yep. We're making a 144 FPS game. Fantastic.
Day one, here am on my own without you, wishing that didn't go. Day two, same again, comes and goes, breaks my heart, no one knew.
So, sprite enemy. Right. Sprite SPR. Enemy. import. That's the enemy. Jeez. Going middle center. Object enemy. Side sprite. Create event for our enemy object. Create event. Assign variable. It's got 5 HP. So starts with another variable for the speed. We want the meta to be move it.
Didn't wanna go. 'Cause out here, I'm all alone. Didn't wanna go. I wanna turn back the time and let you know to come home.
Okay, we need to add a step event. Step. So once every game frame, we're gonna check for player instance in the room. If one is found, move towards it. If instance exists, there we go, I haven't used that before. So if object player exists, set point direction. Where are they here? To ABJ layer.x, ABJ layer.y. Set speed. Speed. Set instance rotation. Direction. If variable HP is less or equal to 0, then destroy instance. Object bullet. A collision event. Collision with enemy. Assign variable obj enemy.hp -1 relative. What? Alternate is within the room. Doesn't know which one you actually want to affect, so we can't write that. There's only one unique instance to be accessed, instead we need to first of all tell to apply the scope the other instance of the collision. Aha, okay. Where does the apply to? Assign variable -1 H, and then destroy the bullet. Whoa, they're fast. Ah, crap. What layer are they going on? Let me try that. Alright, so then we're going into the collision masks. Alright, so we're going to take a quick 10-minute break and come back to keep going on with this tutorial. Looks like we're about halfway. Let's turn that background music up. We'll be back soon.
Does anybody know her name? Does she know I feel the same? Does anybody know her name? How does she feel? Does anybody know her name? Does she know I feel the same? Does anybody know her name? How does she feel? Does anybody know her name? Anybody know? Does she know I feel the same? Does anybody know her name? Anybody know? How does she feel? Does anybody know her name? Does she know I feel the same? Does anybody know her name? How does she feel?
Alright, and welcome back to XP Studio. I am XP Dev. We had planned on starting to work on a platformer tonight, but the tutorial for that is going into some more advanced stuff that we haven't learnt yet. So we changed to this arena shooter. We currently have some enemies that will run towards us or move towards us. Whoops. They don't do anything to us. And they'll just sit on top of us. And they all bunch up on together then. So obviously that's not great. If we restart it again and don't let it do that, you'll see we can shoot. They've got 5 HP each. We do 1 each time we shoot them. We can kill them all, but then nothing else happens. Oh, the other thing you'll notice as well is that's just we're about to work on. The sprites for the bullets aren't exactly hitting the enemies, so we need to change the collisions, which is what we're about to start doing. So, we're going back to the sprite editor for the bullet. The ability to set up collision masks. So the bullet, open the bullet sprite now, select the collision mask. Okay. Type mode automatic. Got full image, manual. This section of the sprite ammo permits you to define the area of the sprite that will be used to detect collisions. Where a collision is defined, it's when 2 collision masks overlap at any point. By default, this will be set to automatic, and you can see that in the preview window, set to a dark rectangle. Okay. We want to edit this as too large. Means we have to click the mode button. Select manual. This will open up the options to edit the collision mask, permitting you to change the mask shape, set the values required for the area it covers. We're going to use the rectangular collision mask, but we need to change its size. You can do this by changing the values shown for top, left, bottom, right, etc. However, you can edit the collision mask directly in the preview window by simply dragging the little box handles around it. What we'll achieve is only the head of the bullet, so the rest of it won't register. Something like this. Okay. Anything about there? Doesn't seem right on that side. Oops, we've gone up 1 too many. About there. That looks about even. Okay. Oh, they've gone a little further back. Let's go there. Now we need to open the other 2 sprites and edit their collision masks too, as in the image shown below. Okay, so enemy, collision mask, mode, manual. Something like that. Maybe in a little bit more on that side. There we go. And same for the player. Manual. Can we go circle? They're slow. Rectangle with rotation. Let's drag them in a little bit more. Alright, cool. That side is in bottom. There we go. Okay. Most arcade games, collision masks get smaller than the sprite to give the player a little bit more room for error, and in this game we'll do the same. Before we end this tutorial, let's quickly add a collision for the player colliding with the enemy. So, object player, add collision with enemy. Okay, so we're literally just going restart game. Okay. So let's just test that. I'll pull those enemy sprites in a little. Cool. Alright. Tiles and views. Okay, so to background to a game, we want to use a tileset resource. Tilesets are based on sprites. Although so far we've only used sprites for game entities like players, we can also use sprites for backgrounds and tilesets, which can also be animated and do other interesting things. First thing to do is to create a new sprite resource. Okay, what? Tiles we're going to use are the 128 by 128, all placed in the same image in a grid. Tile sets are always comprised of a single sprite image, and you must always be based on a grid, although the grid does not have to be square, just regular. You can have 24 by 96 or 32 by 32 as long as part of the tile set image is on a grid. It can be used in Studio Maker as this tile set. Note that the top left corner of the tile set sprite is empty. Okay. Add a tile map layer in the room edit, which covered in a moment will be empty. You won't see anything, but it's actually filled with these blank tiles. When you start to paint tiles on the map, if you delete a tile, it's not actually being removed, but instead it's being changed to this empty tile too. Note, even if the image you supply has non-transparent pixels in this first grid cell, they will not be drawn to when making tiles. Let's keep this in mind and just leave the first tile blank. Okay. Okay, create a new sprite. SPR. Background. Import. Okay, you need to make a new tile set resource. It's done by the same for our sprites and objects. Right click on the tile reset resource folder and select create. Create tile set. Tile background. Okay. Change covenant group by 16 by 16 set per cell, which shows the way the image will split to create the final tile set cells. If you have used the tutorial image, you can probably tell the current settings are way too small for the image we're using. Above image, you see we have marked the first two sections of the tile set properties. Let's control the tile set height. First you need to set each of these values to 128. The rest of these values can be left at the default as they're used for creating offsets and split distances. Basically some tile set images may be created with empty tiles around each tile, so you can set the pixels or cells between each individual part of the image. Our tile set has all the tiles packed right beside each other, so we don't need to worry about this. Our tile set is now set up and ready to add to a room. Tile map layers, need to go back to the room editor workspace. Okay. Create a new tile layer. Okay, open. Tile set selected will now open on the right. Click on any of the tiles to select it for painting into the room. Now we need to paint the tiles in a way that makes sense for the room and the tile set chosen. So select the appropriate tiles to make the final tile map look like this.
You look to the sun, but you got nothing left to give. You feel you're on the run.
Okay.
It seems you don't know how to live. And when we lose our way, we all deserve to find belief. 'Cause we're on top of the world. Our lives in front of you and me.
Alright.
You look to the sun, but you got nothing inside. You should be bursting at the seams. You feel you're on the run, but you got nowhere to hide. You don't remember how to dream. And when you've lost your way, feel
6, 7, 8, 9, 10, 11, 12, 13, 14, 16. 35, 128, 2048. Okay, so let's go. Two, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1280. Okay. 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 New room properties. Viewports and cameras. No. We need to tell GameMaker Studio to only show a portion of the room using a camera view. We can set this up from the room editor too. From the section tiled views in the room properties. Let's go to the viewports. Okay. Enable viewports. No matter how you set things up, if you don't enable views, then nothing will change. This is very important. Make sure you expand the section on view 0. Okay. Next you need to expand the section on view 0. Multiple cameras in the room. They can be enabled to display at different positions, permitting, for example, a 2-player split screen game with camera view for each player. However, for our game we only need one, and that's the camera view 0. Okay. A lot of options here, but we need to switch the view on. Okay, visible. Rectangle up here in the room to show where the nice view will be placed. View camera rectangle is defined from the view properties, X and Y. Okay, what? You can also set the camera viewport, which is what defines the area of the screen that we use to display the camera view. It's defined from the view cameras of the X and Y. Finding the size from that view, from that point. This view camera rectangle is defined viewpoint, which defines the area of the screen that we use to display the camera view. As you can set a camera to be any size and set the viewport to be a different size. The camera will be scaled to fit in that space. You can have a camera that's 480 and make a camera port 960 will be scaled up to fit. However, for our game we're keeping things simple, so these can be left at their default settings. Final thing we need to do is set the object following. By default, a view camera is static, it won't move unless you code it to, but we can set to follow an instance of an object automatically and without code using this button. Once you've set it to follow the object, we need to set the horizontal border and vertical border values. Just to state how close to the edge of the view the instant needs to be before the view camera will move to follow it. At the moment it's 32 pixels, which means that the player would have to move right up to the edge of the view camera before it will move to follow, which is in an arena shooter like ours just too small. We want to move before that so the player can see what is around them. So set these to 256 each. Notice we leave the two speeds at -1. If we set this, then we are telling the view camera to only move by a specific amount each game frame. So if we set to, for example, 5, then the view camera will have to follow player only 5 pixels per game frame. This can be useful and give a nice little catch-up effect if the instance being followed moves faster than the values given. But not for our game. We want the camera to always stay centered on the player, so we leave it at -1, which is essentially telling the camera to move instantly to the instance being followed. Position every game frame. Okay, so let's make that 4. Okay. Alright, so creating a score object. Assign variable. Create. Assign variable. Score. Draw. I've only been back on for like 15 minutes. I've only been back on for like 15 minutes. Just hold on a sec. Let me just finish this section. Okay, here's the multiple. Add, draw event. Defaults using the draw self action. This action will also draw the assigned sprite along with any applied transforms, just like the default. When there's no draw event, now when you add a draw event to an object in it, add some action blocks. You're telling DrawMate you want to handle what is being drawn. No longer draw anything except what you have put in the event. So it won't draw the assigned sprite unless you tell it to. You can draw any sprite, it doesn't have to be the assigned one. The general draw event and all other draw events will be performed once for every game frame, much like the step event. Note that you can have unrelated actions in the draw event as well as draw actions. I recommend you keep this to a minimum and use the step events instead, where possible. However, all drawing must be done in the draw event. In general, placing draw functions in any other event will not work. So before we continue, it's worth noting the draw events have other general drawing. Will affect the instance default drawing, so that you can, for example, have no general draw event but have a draw end event for the instance will still default draw the sprite whatever you have added into the draw end event. If you want to know more about the different events, so category open the manual. Alright. I've just got to be back, go away for just a moment. I'll be back in just a few minutes. It won't be normal length of a 10-minute break. It'll say 10 minutes on the stream, but it won't be that long. We'll be back very shortly.
her name? Does she know I feel the same? Does anybody know her name? How does she feel?
My apologies there. My partner's just going to bed. Say goodnight. Alright, so where were we? Okay, so setting up variables for the score. We need to set it to follow the what's the name? The camera. So we're setting just a draw event. Yeah, that's alright. Just a draw event. So it's going into far more detail. It should have definitely been the first tutorial. Okay, we're getting the ID for the camera assigned to viewport 0. Using the built-in global score array view camera. And storing it into temporary variable VC. Alright, so declare temp VC view camera. Camera 0. Multiple viewports active in a room up to 8, starting at 0, so it's view camera 0, and you can assign a camera to each one. So referencing, for example, view camera 3 will mean you are dealing with the camera assigned to viewport 3. In this case, for viewport 0, since it's the one we set up in the room at the last section. Here to get the position of the view camera within the room space, we use the declare temp action 2 more times. Okay, so CX, camera X, camera get view X, VC, CY, camera get view Y, VC. These functions will return the XY position of the view and store each one in the temporary values CX, CY. We previously declared temporary variable here, so we want to get final value now so that we can position the text correctly in the middle of the screen. So add a final declare temp action. CW camera get view width VC. And with the values in our temporary variables, actually drawing the text requires a single action, the draw action. Draw value action. Okay, I can see what they got there. Is it just quotes? Yep. Score CX plus CW divided by 2. Oops. CY plus 25. Okay, we'll do is position the view within the room and then using those values to position text, we want to draw the relative position. And that will move the view, more specifically, you will always be at the top of the viewport and centered. If that's done, you should have a full set of actions that look like this. You drop this instance into the game mode, but all you'd see is 0 on the screen since we don't actually add to the score value yet. So let's do that now. Get our score as we go up as we play. Some extra actions into the step event of object enemy. Okay, so step event object enemy. Need the enemy to add a value to the score object variable score, and so for that we will use the applies to option in an action. Okay, we want assign variable. So, score. Okay, now it'll add 5. Need to add that to the room. Instances. Okay, styling text. Font score. Okay, new, create font. FNT. Score. Set style bold. Size to 24. Okay. Check score. Declare temp. Where's the draw? Set font. That's a score. Set draw color. False. What have we broken? Okay. Okay, so sound, create sound, SND, this,
Put it on the right track, put it on the right track. Message from my heart, message from my heart. Put it on the right track, put it on the try my heart. Put it on the right track. Put it on the right track. Message from my heart. Message from my heart. Put it on the right track. Put it on the right track. Message from my heart. Message from my heart.
Yeah, because we built this from scratch. So there's no... Alright. Zero. Gross sounds. Explosion. Okay. So back to enemy. Random. Sorry, 8, 2. I already did that. Okay, ebony samurais, I'll set up outside. Total page sprites.
You look to the sun, but you got nothing left.
Okay, a couple of sprites, one for the background, one to show the game title.
It seems you don't know how to
You can use sprite, BG tile dark.
lose our way. We all deserve to find belief, 'cause we're on top of the world. Our lives in front of you and me.
Change the origin. Middle center. Okay, create new room. In the background layer. Yep, okay. Vertical, horizontal tile. $20.48, $14.08. Okay. Okay. You create a new object, object title. Assign it the title sprite. Create. Okay. Set instance alpha 0. Add a step in that. Site variable. No set instance alpha. 0.2 relative. Variable image alpha is greater than 1. I'm gonna change this. Oh, because I haven't added it to the room. Excuse me. try that. Alright, was there a... Hello, thanks for the follow. We're learning how to use GameMaker, and in preparation to make our first game from, as the studio name suggests, 0xp. So we've pretty much made this game that we're making. It's a little arena shooter. Problem is, I was trying to make a larger window size. I'll go back to what the setting was. So we had a... Oops. 1408. We had a screen size like this, but it's not changing to what was a smaller size once we got into game. So I've been playing around with some settings, and I'm just looking for, at the moment, something to do to Windows state. Something about changing window size. Camera. The closest I found is the Windows state, but it will only go full screen. Toggle between window and full screen. Guess we'll put the size of the room back. Still got the right camera setting size. Okay. Oh, we need to test that the game restarts if you die. Okay. Okay, so back to the game. We're essentially gonna remove all of those, creating a new instance layer. Enemy layer. Okay, we need a new object for the enemy spawner. So an object spawner. So on the object the enemy sprite too. Okay. So set instance scale. Create event. Any difference? Just add an extra line. There we go. I like that better. Alright, so set this to scale. So I'm going to do this the same. We're putting spawners there. Okay. Enemy layer. Okay.
Message from my heart. Put it on the right track. Put it on the right track. Message from my heart. Message from my heart. Put it on the right track. Put it on the right track. Message from my heart. Message from my heart. Put it on the right track. Put it on the right track. Message from my heart. Message from my heart.
Why isn't it doing anything?
You look to the sun, but you got nothing left to give. You feel you're on the run. It seems you don't know how to live.
I'm an idiot.
When we lose our way, we all deserve to find belief. 'Cause we're on top of the world. Our lives in front of you and me. We are on top of the world.
Change object instance. Okay. Spawn right. Create new object. Okay. Alright, so now we've got the object spawner. Totally do that in one object without the event extra object. Oh well. Okay. Create event. Assign variable. Spawn rate 60. Set alarm. Zero. Okay, so get random decimal and width 6. Get random. Instance. Enemy spawn. Spawn rate. Okay. Oh, I need to put the spawn on. Right. 2 seconds. Okay, that's better. What about that wall? I mentioned about a wall. Okay, in a later tutorial. So where is that? don't know where it is. Okay. I can't seem to find it. Unless it's in one of these. Alright. Well, that's all done for that tutorial. Alright. curious about this whole time stuff, whether it has to be by frames. So, I have the GameMaker manual favorited, so design by frames or by time. Alright, let's throw this sound down for a second. Curious about these videos.
この企画ゲーム設計のカテゴリーではゲームのアイデアや仕組みを考えるときに必要になりそうなことをまとめたいと思います。企画書の書き方などの体裁は別のところにしようかなと思います。ゲームをよくプレイするならご存知の方も多いと思われますが、大前提なので解説します。ゲーム業界で扱われるフレームというのは、大抵の場合は画面を書き換える描画単位のこと、映写機のフィルムのコマのようなものです。標準的なテレビなどでは秒間60枚の画面書き換えを行います。つまり秒間60フレーム。これがゲームの単位時間として扱われることも多いです。距離イコール時間かける速度。時間の単位は物が動く場合には速度や距離の計算に大きな影響を与えますから、このフレームの送り速度は非常に重要な役割を持ちます。秒間60フレームと30フレームでは見え方や操作の滑らかさにもかなりの差が出ます。YouTube 上で正しく見えるかどうかは分かりませんが、ご覧の通り。ゲームはできれば60フレームで作りたいところですが、30フレームを標準にする場合もあります。少なくともパフォーマンスを30フレームの半分に落とさなければ60フレームにならないですからね。30フレームでもゲームは差し支えなく遊べる範囲ではあります。実際映像作品などは30フレームが標準的ですから。フレーム数はゲームごとに一定にしているわけではなく、その機種や処理によってまちまちです。可変フレームレートといって処理が重い時だけコマ数が減る場合もありますが、これはいわゆる処理落ちとは少し異なりますね。ゲームの速度は変えず描画だけが落ちるとか。PC ゲームやハイエンド機種では秒間120フレームや200フレームを超える描画処理を行われていることもあります。マシンが対応していてもモニターが対応していなければ意味がないので、ぜひ揃えたいところですね。滑らかヌメヌメで最高です。さてここで昔話をしますが、ファミコンやスーパー製でしたから、ところが欧州フレームになったゲームの、ファミコンやスーパーファミコンパルにそのままと、これからも早かったかな、わかります。すべての動作はフレームが基準なのです。だからになります。多分こんぐらいで合ってるかな。1と2と3という感じの間には15フレが2つある。15フレというのはスマブラで言えばおおむねスマッシュ攻撃が入力されてから攻撃が出るまで。 鉄拳などでは普通のキックが出るまでぐらい。ストリートファイター2の強パンチの出だしはこの半分弱かも。もちろんキャラや技によってまちまちですが、こんなスピード感です。で、例えば20フレームというのは15フレーム強ですから、0フレと30フレームの、中央部分より少し長いぐらい。この基準点をどれだけはみ出しかによって、目安をつけます。レースゲームのゴールがどのような流度で測っても正確にタイムを出すのはこのような方法で作れます。フレームとフレームの間を、距離で測る。とりあえず秒を打つのに、1と2と3というふうに間を入れてみましょう。あとは慣れです。一例ですが、以前ディレクターが頭の中で思い描いた動きをスタッフに伝えるため、
Hi, Aryan here at GameDevBox. One common way gamers measure performance is with frame rate or frame per second, FPS. However, FPS can be a misleading metric when developing your game. A common issue for beginners is that they get something like 1000 FPS in an empty project and feel happy until they add a few objects, and their FPS drops by half. Suddenly they got shocked, angry, yell at the engine. That's why we recommend using frame time in milliseconds instead of FPS. Here's why. Take a look at this graph comparing FPS and frame time. For instance, if your game runs at 900 FPS, each frame takes about 1.1 milliseconds. At 450 FPS, each frame takes 2.2 milliseconds. Even though FPS appears to drop by half, the difference is only 1.1 milliseconds per frame. To calculate frame time, divide 1000 by the FPS. For example, 1000 divided by 16 FPS is 16.6 milliseconds per frame.
Hey guys, today I'm going to be giving a little bit more of a walkthrough and demonstration and speaking more on a matter of principles as opposed to a technical walkthrough. I'm going to be showing the pros of why you would want to use time-based logic over step-based logic. And I think that can best be demonstrated through just a literal example. So here we have two squares that are moving at the exact same speed for now. So we have an FPS of 60 frames per second. And that converted, I did the math already, took care of all of that stuff. That converted into either 72 pixels per second or 1.2 pixels per frame, assuming that we set off at the initial speed of 1.2 pixels per frame. That's like an H speed, the H speed keyword. So let's say you're playing your game and your FPS dips. So you can scroll down to change that. So if you see here, if you ever get like a stutter in your game, the time-based movement actually continues at the exact same speed you want. As a matter of fact, if we stop and shake the game like so, and the game technically pauses, and then we let go, that square actually finished the loop and kept going. See, we sit here, we jiggle a tad, and we let go, and actually kept moving. Meanwhile, the step square paused entirely when the game did, and it relies entirely on the actual frame rate. So if I scroll up, bring it back up to 60 frames, not only does it actually take a second for the real frame rate to catch up, which dives back down every now and then entirely out of our control, but let's say they're roughly now moving the same speed. So let's say one day you realize you want to run your game at 120 FPS or 140 FPS. So we tune that up. Let's go all the way up to 140. So now this is moving super fast. It's moving way faster than the time-based one, right? So now you've actually affected the player's experience. Everything is moving over 2 times faster. So now you have to go everywhere in your code and hunt down everything that's frame-based and adjust that accordingly. And then let's say you want to change the frame rate later on. This is horrible. So the time-based stuff, it's always consistent. You always consistently get exactly what you want, regardless of the frame rate. This can be used for movement, like so. It can also be used even for animations. Let's say you double the frames of an animation and you double the frame rate of your game, but then you still want the animation to take place over the same amount of time so that it doesn't affect the player experience. It actually just makes the animation visually look even smoother. See, that would be an instance where you would want to use a time-based animation. So there's a bit more computations that go into this, but I swear it's absolutely worth it. It's a little bit more of an advanced topic. You can download this project file. I always include the source code with everything I'm demonstrating if you want to take a look at a bit of the math that's going on behind the scenes and try to implement it into your own project. As a matter of fact, it looks like I could maybe spin a game off of this, some sort of time-based game of racing, or maybe there's some pickups and it affects the frame rate of the game. That could be an interesting little concept because this looks like a little bit of a track racer. Okay, so I hope that clarifies a little bit on why you would want to use time. It's objectively better. It is a little more complicated, so you might not always need to use it, but for bigger projects where you need things to be exactly the way you want, things to be happening exactly how and when and why, all on a matter of time, that's when you would want to use that. Okay, I appreciate it. Thank you for watching, and I'll see you next time. Bye-bye.
think it's got to do with the delta time. Set the static step-based horizontal movement. This is also the same as putting self.x.
Hey there, in this tutorial we'll be learning about delta timing. So let me explain what delta timing is. Let's say your game runs at 30 frames per second and each frame the player moves 1 pixel to the right. So in 1 second the player moves 30 pixels to the right. Now let's say the game slows down because of performance issues and runs at 10 FPS. In that case the game only gets 10 frames per second, so in a second the player moves 10 pixels to the right instead of 30. So that's considerably slower than what you want. This is where delta timing comes in. Using delta timing, the speed is multiplied by a certain value so that the player moves 30 pixels to the right no matter what the FPS is. So let's get to it. In this project, I have an empty manager object and a player object. It has the move speed in the create event and the movement code in the step event. It simply gets the horizontal and vertical input, multiplies them with the move speed, sets them to HSP and VSP, and then adds them to X and Y. And this is how fast the player should move. Now I'll open O Manager and add the create event. Here I'll add this. This will set the game speed to 10 FPS, so we'll use this to test our delta timing. So I'll run the game, and you can see that the player moves a lot slower. So I'll go back to the create event and comment this line for now. Then I'll add this. The global delta factor variable will hold the value that will be multiplied with the speeds. So I'm initializing it at 1. Here I'm creating a macro called delta for global delta factor. So basically you'll be able to use the variable global delta factor by only typing delta. So you won't have to type the longer name each time you want to use it. Now I'll add the begin step event and add this here. Delta time is a variable that tells you the time that has passed between the previous frame and the current frame. So if the game is slower, this value is larger and vice versa. This value is in microseconds, so it has to be divided by 1,000,000 to convert it into seconds. And since our game has 30 frames in 1 second, I'll multiply this value with 30 to get a normalized value. But if your game runs at 60 FPS, you can set this to 60. So if the performance is fine, this value should be around 1. This function will print the delta value in the console. So I run the game and you can see in the console that the delta time stays around 1. Now I'll go to the create event and enable this line for a low frame rate. I'll go to player step event, I'll multiply the delta value with the movement speeds. Now I'll run the game, which is running at 10 FPS, and if I move around you can see that the player is moving at the regular speed. The speeds are being multiplied by 3, so at 10 FPS it functions like 30 FPS. Now I'll go to OManager's begin step event and comment this debug line. Now we also need to add delta timing to alarms. After an alarm is set, its value is reduced by 1 each step until it reaches 0 when the alarm is executed. So if the FPS are low, alarms will take longer to run. To fix this, we'll create our own alarm system. So I'll open the create event and add this here. When an alarm is inactive, its value is -1. But using that value can cause some problems with our custom alarms, so we'll use a lower value, -100. Using this for loop, I'll create 12 alarms in this array, all set to the inactive value. Now in the begin step event, I'll add this. This loop will go through each alarm in the array. If the alarm value is greater than 0, the delta value will be subtracted from it. So the alarm will count down based on the delta speed. If the alarm is at or below 0 and it's above the inactive value, the alarm value will be set to inactive and the alarm event will be run. So for each alarm, it will count down if it's greater than 0 and when it reaches 0, the alarm will run. Now for testing this alarm system, I'll open the create event and add this here. Here I'm setting alarm 0 to 30, which is 1 second, and creating a variable for counting those seconds. I'm using the built-in alarms here and not my alarms, which use a capital A. Now I'll add the alarm 0 event and add this here. This will print the second value to the console, increase it by 1, and then set alarm 0 to 30 again. And now I'll run the game. You can see the seconds appearing in the console, but they're appearing too slow because the game is running at 10 FPS. Now I'll change the lowercase a to an uppercase A so that it uses my alarm system and then run the game. You can see now that they're appearing at the correct time because of delta timing. So using delta timing, you can make sure that everything moves at the correct speed at every frame rate and that every alarm runs on time. So that's all for this tutorial. I really hope.
Today I want to show you how I went from getting
Alright. Let's go back to those tutorials for a sec. Let me have a look at that one. Alright. Probably do one of those ones.
It's been 4 years since
I'm gonna look into this video on my own time. So that will be us done for the night. We're gonna be back next Tuesday, the next episode, with more tutorials from GameMaker. I'm still not confident ready to start making our own game yet, even though we're gonna still be following tutorials the entire way through that. I just wanna keep going, make sure I'm used to the tools. There's still more ones that I haven't used yet. Even in that first one we opened up tonight, there was going into stuff I hadn't seen at all. So that's us for the night. As I said, we'll be back next Tuesday, 8 PM Australian Eastern Standard Time. That's Brisbane GMT plus 10. And in the meantime, enjoy your weekend, and we'll see you then. Have a great night.